If you've been following along, you know that I don't think the current black hole theory is correct. The current black hole model is of an event horizon which surrounds a singularity. So it looks something like this. So you have an event horizon where the theory is you cannot escape the black hole's gravity if you fall below that event horizon. And you have a central singularity. Now the actual model here, event horizon, central singularity, that's not something I can argue. There was a time when I would have said, oh, there's black holes are non-singular. And that's no longer really the case. I have to attest that this is the black hole model that I have to deal with. What I'm disagreeing with is, let's have a test particle here outside the black hole. And what it's going to do is fall below this event horizon. The event horizon is the point from which there is no return. You fall below the event horizon and into the singularity. That's what I'm arguing against. That's what I don't accept. Let me explain it very quickly why. My position will be based on the concept of null geodesics. What are null geodesics? No object in the universe can go faster than the speed of light. That's I would call it the founding principle of relativity, is saying that well, special relativity and general relativity would be that you cannot exceed the speed of light. So, as a way of illustrating this, the idea of light cones was developed by the Lorentz transformation. Let me just draw a light cone right here. And this light cone, of course, represents the speed of light. And everything inside the light cone is moving slower than the speed of light. If it goes outside the light cone, it's moving faster than the speed of light, so you can't go outside of this light cone. So any kind of test particle moving through the universe has to move in between this line. Actually, I can't really draw that because I think the angles might have been 45 degrees there. Any object in the universe has to move within this light cone. It can't move outside of it. Now, in general relativity, this is for flat space-time. A 45 from this median here. There's a 45-degree angle on either sides of this light cone to say you can't go that way faster than the speed of light, and you can't go that way faster than the speed of light. Now, in general relativity, the same idea of a light cone is carried over into what are called null geodesics. And these are lines of light which move around the curved surface of space-time in gravity. Since gravity curves space, gravity curves the path of light. So let me talk very quickly about geodesics. We're going to assume that I'm actually going to go up right here. We have a point A and we have a point B on a curved hilly surface. So that means that the geodesic, a geodesic is the shortest path between 2 points in curved space or on a curved surface. So the geodesic between A and B might be something like this. And there's no problem there. I can travel from A to B along this geodesic on this hilly curved surface. Let's also assume that there are points C and D. And the geodesic for C intersects with the geodesic between A and B, and it comes off of that geodesic to travel to D. And we're going to call this point G, and we'll call this point H. So nothing's going on wrong here. We just have two geodesics that share the same path on the surface between G and H. And this should be absolutely normal. I know I can travel from A to B on a geodesic. I can travel to C and D on a geodesic. It's just those geodesics share a common path between G and H. So what does this have to do with black holes? Well, in general relativity, what you deal with are coordinate transformations. And coordinate transformations lets you look at the space differently. It doesn't really change anything. If you can imagine going to a field and deciding if you wanted to play football or baseball, you'd have to draw a baseball diamond on the field, or you'd have to draw a football field on the field. You're not changing anything about the field, you're not changing anything about the gravity, you're not changing anything at all. You're just drawing different lines so you can do different things on the surface. And coordinate transformations can be much the same. For this action of traveling along these geodesics, I could have polar coordinates, which would be, radial, like this. I could have Cartesian coordinates, which would be kind of a checkerboard. Or I could have curvilinear coordinates, perhaps, that would line up with the surface and allow me to trace along the geodesics. For any one of these coordinate transformations, I'm not changing anything about the geodesics, I'm not changing anything about the paths. And I have absolutely no problem with that. But there is an issue between G and H. When I move from G to H, the distance between these two geodesics is 0. The distance between those two geodesics will be 0 in radial coordinates. The distance between those two geodesics will be 0 in Cartesian coordinates, and it will be 0 in curvilinear coordinates. So no matter how I transform, I know that the two geodesics will have 0 distance between one another, between G and H, in all coordinate systems. So let me apply this to null geodesics of black holes. In black holes, this light cone, these null geodesics, remember we were talking about them, everything has to be inside these light cones. What happens is they shrink up. And I'm going to draw this line. This is going to be the event horizon. So I'm going to draw 45 up here. Well, that's a little bit bad. Draw them shrinking. And eventually at the event horizon, they close. Let's straighten this. So the paths that particles can take in the universe close off in these light cones. And eventually you get to the event horizon and the light cone is closed completely. And that means that there's no path for anything to take inside the event horizon. So that means all paths for all particles should be asymptotic, approaching the event horizon, but never making it there. So why then, why is the current theory held that you fall inside the event horizon and fall into the black hole? The claim is because there are coordinate transformations which are made that allow you to plot these paths below the event horizon. However, at the event horizon, the light cone is closed off completely. This is what a light cone looks like at the event horizon. It is the same principle I drew it wrong here. Just as there was no distance between there's no distance between the null geodesics between G and H, so also there is no distance between the null geodesics at the event horizon. And just like here, where no transformation can put space between the geodesics when they're in the same dimension with one another, there are no transformations that can put space between the geodesics in this coordinate system. Such transformations which have been suggested that do this action are the Eddington-Finkelstein coordinate transformations or the Kruskal-Sasekaris transformations. And the idea is that they both create 45-degree light cones at every point in the field. So you transform the space so that when you look at it, there's always a 45-degree angle between the null geodesics. And again, you're not changing anything. That's just a way you're looking at the space. The difficulty is that there's no way around the fact that at the event horizon, the geodesics are in the same dimension, and there is zero space between them. And that's why the current black hole theory is wrong. The current black hole theory is wrong because it presumes to put distance between geodesics which simply cannot, by definition, have any distance between them. And when you recognize that, then you accept the fact that nothing falls inside black holes. And that leads you to another development in physics, which is called asymptotic darkness. And from asymptotic darkness, you can derive a model of the black hole which is similar to a proposal by Professor Samir Mather called the fuzzball black hole. And from there, I suggest it's a jumping off point to understanding dark matter through sustained Einstein-Rosen bridges. But that's a lot of mathematics that is currently out of my pay scale, let's say that. But that's why I've put this theory forward. I think that this great error has been made, this great error can be fixed, and it can be fixed with this simple demonstration. And when it is, everything else regarding at least some of these mysteries will be elaborated. It's not hard to understand. Like, why do black holes in very distant galaxies, supermassive black holes at the center of distant galaxies, why do they align their rotations with one another? Which does happen. Why does that happen? Because there's an Einstein-Rosen bridge between them, and that bridge twists all the way along so that they share a common spin through their Einstein-Rosen bridges. Why does dark matter appear in halos and cluster galaxies together? Because they're connecting galaxies together, and the tension on those bridges draws the galaxies closer with greater gravity, curves the surface of space around them more, and creates the dark matter phenomenon. The principles are very, very, very simple, and all of the material is there. It's all ready and waiting to be used. The problem is the black hole model is wrong. That's the entire problem. Nothing falls below the event horizon. Nothing goes down into the singularity. Why is there an event horizon and a singularity? Well, the event horizon is a coordinate singularity, and in the center of the black hole is a physical singularity. Well, that is the model for a pseudosphere, which looks something like this. I'm drawing half of it anyway. Here we have a coordinate singularity perimeter, and infinitely far away on this surface there will be a physical singularity. It's just the cross-section of a pseudosphere. And why wouldn't it be a pseudosphere? The metric that's being used is the Schwarzschild metric, which is a spherical metric. And if you invert a spherical metric, you get a pseudosphere. Is there inversion at the event horizon? Yes, because the metric goes from, let's use along the diagonals, negative, positive, positive, positive. It goes to positive, negative, positive, positive. So those time and space values between 0, 0, and 1, 1 flip over. And that's math that you can do just looking at the Schwarzschild metric. So you know there's an inversion at the event horizon. You know that below it, it makes sense to say space-time inverts because everyone's already saying, look, you go below the event horizon, time runs backwards relative to the outside of the black hole. And suddenly you're just dealing with geometry. And that geometry leads you directly into other sciences, other explanations that already exist. You know, asymptotic darkness has already been described. The fuzzball theory, already out there. String theory, already there. Einstein-Rosen bridges, everything is the table is set. The only problem is this. That's it.